So in this lesson, what we're going to do is we're going to talk about some basic definitions that we're going to use to help us simplify algebraic expressions. And these definitions are going to be used as justification for our steps. Because you just don't do a step, you have to prove to me that you can actually do that step, and that's called a justification. So in the very basic beginnings, we start with definitions, the definitions that kind of make everything work. And the first one is the definition of subtraction. And we learn this when you study, adding and subtracting negative numbers. And you learn the definition of subtraction is adding the opposite. And so we're going to use this to justify simplifying signs or unsimplifying signs. All right. So for example, if I take 3x minus negative 4, and remember the rule says of criteria for simplified expressions, you can't leave minus negative. You can combine that and simplify the signs to a plus. And the justification for that, the mathematical reason we can do that, is the definition of subtraction is adding the opposite. And so my justification to everybody, to prove to them that I can do this, is the definition of subtraction. Now we're going to use this property both directions. So you're also going to use it in such a way that if I have 4 minus 3x, that is not simplified. I don't want the 3x in the back, it needs to be in the beginning, but I just can't rearrange subtraction because subtraction doesn't work that way. So what I have to do instead is change it to 4 plus negative 3x, and then I can totally rearrange things. And doing that, or unsimplifying the sign, is also the definition of subtraction. The next one we're going to use less often is the definition of division. And so that's when I have like x divided by 3 written like this, or x divided by 3 written like that, and I change it to x times 1/3. So whenever I change division, either with the vinculum or with the obelus, into a multiplication by the reciprocal, then I totally have the definition of division being used. So this is an example of the definition of division. The next property, and we're going to use this one a lot more often, is the definition of exponents, or the definition of powers. You can use either word, they're interchangeable there. And you use this property whenever you write something as an exponent. So x times x times x times x is not the fun way to write that, or efficient way I should say, and I would write that as instead x to the 4th power. And this here, rewriting this way or that way, either direction, is a definition of exponents, because sometimes you want to combine them into the exponent and sometimes you want to expand them into the definition. And whenever you do that, you're using the definition of exponents. Now the last definition we're going to look at is substitution. Now substitution means to just replace something with something that's equal to it. And we're going to use this as a justification for arithmetic. So this is going to be the justification for basic arithmetic, like adding, subtracting, multiplying, dividing numbers. And this is not variables. We have other properties for dealing with variables. So if I have x plus 2 plus 3, this thing is not simplified, because remember, you have to combine like terms, which means if you can add something together, you better add it together. So x plus 2 plus 3 can be rewritten because 2 plus 3 can be substituted with what it's equivalent to, which is 5. And this is the happy face simplified answer. And the justification, the reasoning, is because I'm going to use a substitution. Okay, I'm going to substitute 2 plus 3 with 5. It also works with, of course, multiplication. If I have like 8 times 4x, and I want to replace the 8 times 4 with what I know it's arithmetically equivalent to, meaning just equal to, I can say 32x, and changing it from that to that is substitution. So the basic definitions we're going to use are definition of subtraction, to simplify or unsimplify signs as needed. Definition of division, to change division into a multiplication problem, because dividing is the same as multiplying by the reciprocal. And then we're going to do the definition of exponents, when either I want to expand out an exponent into its defined multiplication problem, or vice versa, and I want to change the multiplication into being written as an exponent. And the last property is substitution, and we're going to use that as our justification for basic arithmetic. No variables, like I'm not adding 2x and 3x, I'm adding 2 and 3 to get a 5. I'm multiplying 8 and 4 to get a 32. Those are examples of substitution because I'm replacing with something that I know is equal. So those are our basic definitions.